All right, so we made the scatter plots for the data, but A, how do we know if it's definitely a positive or negative, and how do we know that it actually is linear, right? So you need the linear coefficient, so correlation coefficient. So if I look back at my spreadsheets here, that one appears to be positive, but how good is that positive one? This one appears to be negative, but how good is it? And this one, not sure. And is it positive or negative? Not sure, right? So we think it's a positive and negative, and we're unsure here. But how do we know? How do we measure this, right? So what we use is the correlation coefficient, right? So it's this Greek letter for population, but we're only going to do samples, so denoted as a lowercase r, which is called the correlation coefficient. So, oops, let me get the snipping tool here. Nope, not the snipping tool. I need the tool. There we go. Different tool. Okay, so the correlation coefficient tells you two things. It tells you quality and direction. So quality and direction. Okay. So direction is a positive or negative correlation, right? Is it going up or down as you go left or right? And then quality is how well does it fit the model, right? The y equals mx plus b model or the y equals a plus bx. How well does it fit the model? Okay. So the values are between -1 and 1, right? So unless you're like a perfect algebra 1 problem, you're not going to be 1 or -1. Those are perfect models, right? So like the one we did before, I forget what it was on page 1. What was the one we did? Oh yeah, fixing a broken phone, right? That's a perfect linear model, right? That'd be a perfect positive 1 model, basically. But those are not what we're doing. Simply, they're not going to fit that. So the probability of getting 1 or -1 is, slim to none. And then 0 is basically no relationship at all. But getting that is unlikely also. You're more likely to get 0.00 something or other, basically. All right, so the general idea is what do they kind of look like? So if I had to guess, is this one a positive, perfect one? No, it's not a perfect line, right? But 0.90 is close, right? This one might be a -1 left to right. Is it actually -1? Probably not. It's probably, negative 0.98 or something like that. You know what I'm saying? And I don't know, that's a positive 1. I don't know, probably like 0.75 or 0.7. Who knows? You know what I'm saying? As to what it actually is. Maybe 0.5 might be closer, but these are my only guesses I can make. So that's the general idea of what the R is going to tell me. The negative is going to tell me the direction. The positive is going to tell me the direction. And then how well does it fit that line? So if they're closer to the line, it's closer to 1 or -1. If they're farther away from the line, right, it's going to be closer to 0, right? Yeah, so this one's clearly negative and not fitting really close, right? So maybe that's a negative 0.5 correlation coefficient, right? Maybe it's negative 0.6. I don't know, I'm just guessing here. This one's clearly negative. I don't know, maybe negative 0.8. Who knows? And this one is probably not a 1. It's close to 1, I would say probably, I don't know, maybe 0.95, 0.98. They're exactly perfect, you know what I'm saying? Okay, so let's calculate the correlation coefficient. There's a couple ways to do it. This is one of the ways to do it. I'll show you the other way in a later video. So let's copy this. And we'll paste it in our spreadsheet. Oh, I clicked the wrong space. Let's move this out of the way. And we'll paste this here. Okay, so you look at the things that we need. Let's get this out of the way for now. Okay, and we're going to need the sum of x, the sum of y, x times y, x squared, and y squared. As to what order you do them, and it really doesn't matter. We already have x and y right here, so we'll call that x and that's y. So that's your input-output. We'll do, how about x times y here, and then we'll maybe do x to the second there, and y to the second there. How's that sound? Okay, so then we will box those, yellow those, middle those, and okay, let's copy these to the other ones too, just to make this quicker. Let's get rid of this here. Uh-oh. There we go. Save a little bit of time here. I like it. All right, and box those up. Okay, so x times y, and drag it down, and x to the second power, and drag it down, and y to the second power, and drag it down. Okay, there we go. Do that all the way through, and x times y, drag it down, and x to the second power, and drag it down, and y to the second power, and drag it down. Okay, so those are all our individuals. Now we need our totals, right? So I'm going to do the sum of everything, don't get a pop up there, in this column, right? And then, oh, why did I drag that so far? I don't know. So I'm going to drag this across, and I'm going to fill this in with, I don't know, how about orange, right? So this is the sum of x, this is the sum of y, this is the sum of x times y, this is the sum of x to the second, this is the sum of y to the second. So these are the only things we actually need here, right? These are the only things we need. So we'll put a box around that, center them, right? So let's copy this to here, and then we'll do the sum of all of those, and then drag that across. And again, we'll do bold, orange, box, and center them out, so we know those are the ones we actually need. Okay, maybe let's bold those two, just so we know that those are the ones I want. That's the only ones I care about. Oops, get this out of the way. Uh-oh, what happened? I don't know what happened there. We lost those ones. We'll fix that though. And we have x to the second power, and y to the second power. Drag it down, and drag it down. We'll copy all our things here. Okay, so we want the sum of these data points, and drag that across, and we want to bold, box, orange, center. All right, those are the ones we want. Okay. All right, so going back to the beginning now, we want the correlation coefficient, which tells us about our model, right? This is our model here. How well does it fit it, and what's the direction, right? So, let's, oh, this thing is, why is it scrolling so badly? So let's do, I don't know, R equals, right? Oh, why did I put a 4 there? I don't know why I did that. And we will shift that to the right, right? So copy, paste, paste. Okay, so as far as the formula goes, equals, my trick is you do the numerator divided by the square root of the denominator. When you go inside there, whoops, you need two parts. The x part times the y part, right? So you see there's three things I have to fill in. I have to fill in here, here, and here, which is the numerator, the x part, and the y part of the denominator, okay? So if I go to the numerator, it says n, so I have 1, 2, 3, 4, 5, 6. So a lot of students will say 12 because there's 6 of these and 6 of these, but each of these makes a coordinate. 63, 7 is a coordinate in the graph, right? So if you look on the graph, there's only 6 points, right? Because each pair makes a point, right? And then I just click it after that. So it's xy, that's this one, minus x times y. So I'm just looking at the formula there. I'm clicking on those things. Oh, I clicked the wrong thing like an idiot. I have to click the actual numbers, don't I? I click the actual terms. Okay, so now I got to go to the denominator. So n again is 6 times x squared minus, this is where people mess up, because this is not x squared, this is x to the second. So I have to click on the x and add to the second power. Let me get rid of this, right? Because x squared and x to the second would mean two different things, order of operations, right? So, because you're adding up the x, then you're squaring. Here is you're adding up the squares. So the other one is the y, which is on the right here. So that's 6 times y squared minus, again, don't make this mistake, because this is y to the second. So I'm going to click on the y and do the second power. So that's a 0.98. So that means it's almost 1, so it's almost a perfect positive linear relationship. So that's pretty good. Okay, let's go to absences. Okay. And equals parentheses divided by the square root of parentheses. I'm going to go inside of there. And we're going to add in one set for the x and then one set for the y, right? So let's you know what? Let's copy that and put that over here also, right? Okay, and we'll copy the formula. So in case you don't know it, we can shrink that down too. There we go. In case you don't know it, there's the formula, right? Give me the scatter plot out. Why does it keep scrolling so much? Okay. All right, absences. So we go to here. So this has 1, 2, 3, 4, 5, 6, 7 data values. So 7 times, and it says x times y, which is this one, minus the x times y, and that covers my numerator. And the denominator, we have the x part and the y part. The x part, again, is 7 times, this is x squared, which is here, minus x to the second. And then the other part is the y, which is 7 times y squared minus y to the second. So I get a negative. So this one is not as good of a model as this one. Not because of the negative, because this is closer to 1 than this is closer to -1. The negative says the direction, which is down. If I look at the graph, yes, it definitely goes down, right? Okay, let's do the final one, the ratio one. Okay, so this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times xy minus x times y, and then the denominator part, 10 times x squared minus x to the second, and then 10 times y squared minus y to the second. Okay, so there is our value there for pupils, and that's not very good. So that's saying it's kind of positive, but that's less than half, right? 0.44. That's closer to 0 than it is +1, isn't it? Which is why it's kind of ambiguous here. We're not sure if it's positive or negative, and if it even fits a linear relationship. So that's not good. Is that good enough to say it's linear? We don't know. So that's the next piece, is figuring out the actual equation. Okay. All right. So